go. Hello, Quiz Bowl people that are watching this video. We are in section 10.5 notes. Remember that we skip over section 10.4, so we're talking about vectors. And we finished up example 2, talking about component form, which is just in the triangular brackets. It basically is just saying from the start of your vector to the end of your vector, you're going 6 units in the x direction and negative 9 units in the y direction. So that means 6 units to the right and 9 units down. That's exactly what that's saying, okay? We are now on to the top of the second page, but I'm going to switch things up just slightly, and I want you to go to the third page. You have a blank spot down here at the bottom, and we're going to talk about what it looks like to add vectors together, okay? So draw a vector that looks like this, and let's call that vector u, and draw a vector that looks like, I don't know, this. We'll make him longer, and we'll call that vector v. Okay, this is just an example. So draw those two vectors. Okay, draw those two vectors. We'll put them like that down at the bottom. Okay.
What is the first one?
Vector u. That's a u with a like a little bold face. Okay.
Can we just put U?
U. Sure. Sure. All right. So drawing them is gonna be kind of tough. This is the trickiest part of the whole thing, I think. But you do have questions like this on your homework assignment, so I want to make sure you know how to draw these vectors. Okay? Ready? Clear? Okay, so if I say, that's what those two vectors look like. If I say draw me what u plus v looks like. Draw me what u plus v looks like, okay? What you're going to do is you're going to start with vector u, which is this, I got to go the same direction, this long. Okay, that's what u is. Right? I start with u, and then he starts here. This is where he starts, where u starts, and where u ends. Okay? And if I'm adding v onto that, I'm going to start where I ended and put v onto that, right? So I'm going to put v from here, and I'm going to go make sure it's the same angle, about the same distance. About there. That's what v looks like. That is adding u and v together. Okay? Does that make sense? That's what u plus v will look like, except we will have one vector that represents u and v added together. And it is the start of the start and the end of the end, which is going from here to here. This is really what vector u plus v is. This is vector u plus v. And that's what he will look like. Okay? That orange one, that is what u plus v looks like.
So when they're adding, you're just connecting.
When they're adding, you start with the first one, and where he ends, you slap the second one on there in the same direction, and then you make a triangle out of it. This is the triangle method of adding vectors, and that is what u plus v looks like. So this is your final answer, is what that orange one is. And that is the start of where you started and the end of where you ended, and that's what your vector u plus v looks like, okay? Now, if I was doing v plus u, what's up?
Why'd you make vector v longer than vector u? Because that's how it.
Because this is given to us and this is given to us, right?
Oh, okay.
So I'm just using the same length for those guys. Like u is that length to start with, v is that length to start with. I'm just trying to keep them the same length when I add them together, okay? They have to give you what the vectors look like to start with, okay? Now, what would it look like if I did v plus u instead of u plus v?
The other it's going to be different.
Like I would start with v here, so I'm just going to add them onto here. I would start with v.
It'd be the same.
It would be the same, but I'm going to add u onto v. So I'm going to start, start, end, start, end, right? And this is going to be right here what u, or v plus u is.
Why's your line so jaggedy?
V plus u, because I sketched it. This is v plus u, right? This guy right here is v plus u. So I put the u on the end of v, right? Now, compare. U plus v and v plus u, aren't those the same thing? They're both the same amount.
Reflected.
What?
Yes,
Reflected.
they're the same, but
What do you mean?
it's different problems.
They look the same.
They're the same length and the same direction.
Yeah.
It doesn't matter that one's up here and one's down here, right? But those are the same length and the same direction. That's what they should look like, right? U plus v, v plus u, those are both the same. Okay? All right? Good? Yep. You guys have enough room down there? I'm going to do one more thing.
Yeah.
Actually, maybe like 2 more things. I'm adding.
Jeez.
You got enough room? You got enough room?
I have this much room.
I'll put him down over here. You got that much room? Okay. We're going to be all right. What if I say draw me what, and if you know how to draw this, maybe you don't have to write it. V plus 2u. What if I say that?
Is that one of the extra things?
Yeah, that's one of the extra. I'm going to do 2 more things to you. What if I say draw me what V plus 2u looks like? Start with V. V is like that guy right there. That's a V, right? V plus 2u. So I start with V, and then I add 2 u's. So here's a u, whoop, right there, and there's another u. You see that?
Yeah.
U. Yep. So V plus 2u would look like
You too.
right there.
You too.
This is V plus 2u. That's what vector V plus 2u looks like. Does that make sense?
Yes.
V plus 2u.
I like this.
You like this?
Nice and
Okay.
simple.
All right. Nice and simple. Okay. Now one more thing I'm going to do. Do you have enough room?
Yeah,
Maybe. Maybe. We're going to talk about subtracting.
Oh,
Yikes. It's not hard. Okay. So we said that u plus v and v plus u look the same. This is what it looks like, v plus 2u. You could do the same thing as u plus 2 v's, but v is longer, so it's going to be, bigger spot. Now, let's do one more thing, which is u minus, now let's go v minus u. Let's go v minus u. V minus u. Okay? Good?
Yeah.
V minus u. I'm still going to start with v. V goes like this, right?
But does it just go the opposite direction?
Aha. So u, if I would go this direction, that's what you would look like. Don't graph him. This would be what u was. But negative u is the same, but it goes the opposite direction. Does that make sense?
yeah.
Like if this is u, this is what negative u looks like, or minus u looks like. Okay? So if this is what v is, I'm going to erase this guy, and I'm going to make him go this direction. Right? Okay? So, overall, v minus u would be this guy. That's that orange guy
That would still be.
from start to finish. Okay? Does that make sense?
Yeah,
What?
but is that value going to be the same as when it goes the other way?
No, not necessarily. This is what u plus v is. This is what v minus u is. So they're like completely different direction, and I think this one's even shorter than that one is. Okay. So they will look a little bit different, right? They will look so minus will not be the same, but pluses will be the same. Like u plus v, v plus u, those will be exactly the same. But when you subtract them, they won't look the same. Okay. All right. Does that make sense? So when there's a negative or minus u, you just take that vector, but you're going the opposite direction with him. Okay. So I think about it in terms of like this. Here's u going this way. Here is negative u going the other way. Okay. Make sense? All right. Good. All right. Was that hard? No? Not too bad? Okay. All right, now let's go to the easy stuff. When you are multiplying vectors together, here is vector v. What is happening? I keep getting the same email over and over again, and I keep making it go away. Here is vector v. Do you see why it's a bold-faced v? V is 3, 1, which means that from start to finish, he goes 3 to the right and 1 up. Do you see how that works? 3 units to the right and 1 up.
Yeah.
Okay? Yeah? So maybe the vector starts like this and it goes this way. He's going up. Nope. I'm going to erase that. You don't have to draw this, but anyway. 3 units to the right, 1 unit up would look like this. 3 here, 1 here. Oop, 1 here. This is what this vector looks like, right? From start to finish. That's what he looks like. 3 units to the right, 1 unit up. That's what he looks like. Ish. Something like that, right? 3 units to the right, 1 unit up. That's what vector v looks like. They want me to find the components, which is component form. We still use the triangular brackets of 3v. So I'm taking v and I'm making him 3 times as big, kind of like what we did.
So it's 9.
So what would be the component form of 3v?
12, 9, yeah.
It would be 9, comma, 9, 3. That's what 3v is. They want us to do negative 2v here in just a second. That's separate, okay?
Wait.
Does that make sense? You just take 3 and you multiply by 3, 1. That's it. Easy, right? Because if you add 2 more onto the end of here, making him 3 units long, right? Instead of going over 3 and up 1, you will go over 9 and up 3, right? Okay, that's what he will look like. Okay? Now, negative 2v is just the same thing again. What's the component form of negative 2v? Negative 6, negative 2. Now you're just going back 6 and down 2, right?
Right, it's the same thing we just did. But it's a negative. Yeah, you multiply the
You just multiply a negative 2 through the things. Yep. Does that make sense? Not hard, right? Not terribly hard. Okay. Okay, good. Vector addition. We know what it looks like to add vectors together. We know what it looks like, but what's the component form look like? So they say that u is this guy here and v is this guy here. Those are the components, and they want us to calculate what u plus v is in component form. Negative 5, 2, and 3, 1. What will that look like in component form if you add them together? Negative 2, comma? 3. You add the x's, add the y's. So negative 5 and 3 makes negative 2. 2 and 1 makes 3. Right? We know what it looks like to add u and v together, but component-wise, what it will end up looking like, negative 2, 3. Yeah. Does this make sense? This is the easy part, right?
Yeah.
Okay. Yeah. Yeah. It does not get harder. The drawing part, that's the hardest part. That's it. This is the answer right here. You're just trying to find u plus v. Okay? It will get harder in the next section, like 10.6, but 10.5 is okay.
Next.
All right, next. Okay? Subtraction, u minus v. So I've got u here is 2, 5. V is 6, 1. And I want to figure out what u minus v is. And I'm just going to subtract those components. So I take 2 minus 6 is negative 4. Right? And 5 minus 1, which would be positive 4. Negative 4, 4 is the components. Easy enough? It's like this is as hard as it gets. Okay? They have something funky weird called the 0 vector, which I don't know why the 0 vector even exists, but the 0 vector is 0, 0, which means it's like a dot. It like doesn't go anywhere, right? So every point is technically a vector. It's just the 0 vector, right? Like it has no distance. It's just a point on a graph. So the 0 vector is 0, 0, meaning it's gone none to the right and none up or down. 0 vector. There you go. Okay. Let's go to the back side. 2u plus 3v. I mean, this is a little bit more complicated, but not too bad. So I do this step by step. Okay. I write out what 2u is, and I write out what 3v is here and here, and then I add them together. Okay. So what will 2u look like? Negative 2, 12, and 3v. Oh, v is 2/3, comma, negative 4. What's 3 times 2/3?
2.
2. And what's 3 times negative 4?
Negative 12.
Negative 12. Okay, now I add them together. I just do baby steps, okay? So equals 0, 0, which is the 0 vector. So we end up with just like basically a dot. It's not going anywhere, right?
Nice.
Nice.
Wow.
Nice.
These are
Nice.
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 These
Okay.
aren't bad.
These are not bad. 4w. 4w minus 2u.
So it'd be 8.
Okay, 8 comma, what's 5 halves of 4? 10, 8 comma 10, and then 2 times u.
Where's you? Oh, minus 2.
That would be.
And?
Wait, what?
Or no, 2
It'd
and
be
12.
2 positive, wouldn't
2,
it?
12.
It'd be negative 212. Okay, now, here's the deal. There's a couple different things that you can do, okay? If you choose,
Negative positive 2.
Positive, it's
Because it's a
negative 2
negative
times
2.
negative 1.
Yeah. Negative 2.
okay, now, hold on, just wait, look at the way that I wrote it. If you choose to just distribute the 2 through, which is what I did, right? I just multiplied this by 2, and I left this as a minus sign. If you want, you can multiply by negative 2, but this symbol in the middle must become a plus. Does that make sense? Yes? So if you do that, then it must look like that. Does that make sense? If you distribute a negative 2 through, you have to turn that symbol in the middle to a plus sign, right? If you just distribute the 2 through, you leave it as a minus sign. Okay? It does not matter which one you do. Oh, let's see what our final answer is going to become. What'd you get?
Minus 2.
10, negative 2, regardless of whichever way you do it, right? You should get 10, negative 2 as your final. Okay? So be careful of that if you're ever distributing a negative through. you know, whatever. Okay, good? This isn't hard, right? Not too bad? Okay. All right. No, I guess this might be the hardest thing, but we've already done this. Are we ready to move on?
Yeah.
Last thing. A and B, it says find the angles formed by each vector below whose initial point is at the origin. So negative 3, 4 means that if I start at the origin, he is going 3 to the left and 4 up. Okay? 3 to the left, 4 up. They want to know what angle is made by that.
Oh, lucky.
So negative 3, 4. Okay? The angle that I look at is always this angle inside of here. This is the reference angle, yeah? Okay? How do I find that angle? It's always going to be tangent, right? Opposite adjacent, okay? So tangent of that angle, we'll call it theta, equals opposite is 4, adjacent is negative 3. Okay? I'll slow down for a second. Are we doing okay?
Yeah, and then you
Okay.
do the inverse.
Then we do inverse tangent to undo him, right? Inverse tangent, whoop. And inverse tangent, what's inverse tangent to 4 over negative 3?
Negative 53.1.
Negative 53.1, okay? Now,
You have to subtract that from this.
that is this angle right here. But we always go from standard position, which is from here
Minus.
to here, right?
Yeah.
From there to there. I want to know what this angle right here is.
126.9.
126.9. Do you guys see how we get that?
Yep.
Okay, that's the angle that is made. 53 degrees is just that middle angle. We subtract him from 180 and it's 126.9.
Maybe we just put 126.
126.9 is the final answer. Okay? Does that make sense?
Yep.
Okay? Let's do the other one. We've already done that before, right?
Yeah.
We've already done that before. Okay? 1, negative 3. What quadrant is that in?
The first one. No, just the one.
Fourth.
Negative.
1, negative 3 is down here. So I've gone over 1 and not negative 3. Square root of 3. Negative square root of 3. Okay? And I want to know what that angle is. I want to know what this guy is down here. So still tangent. Tangent of that angle equals
Negative
opposite
3.
is negative square root of 3 over 1. Or you could just do negative square root of 3 because negative square root of 3 over 1 is just that. Inverse tangent. Inverse tangent. You said theta is negative 60. So this guy right here is 60 degrees, basically. I always measure my angle going from here around this direction. I want to know how big that angle is. If this little guy in here is 60 degrees,
300.
300, right? That's what he should be, right? You subtract him from 360. Does this make sense?
Yeah.
Okay, good. We've already done this kind of before when we did polar form, right? You're finding that angle that goes in there. Easy enough, right? And that is all. Do you guys have your homework assignment for this section? No? No? Okay, just walking through the homework assignment. Find the magnitude and component form of each vector. Okay, so number 1, you want me to give this to you first?
Yeah.
So you can look at it? Okay. You are right. Here.
I was just wondering if you take the front side.
There's not a backside even. So starting with number 5 and going all the way through 14. 5 through 14 is exactly what we did today. So I don't know, let's talk about like 1 through 4 just to get us on the same page to remember what we did before. 5 through 14 shouldn't be too hard. That's what we did today. But 1 through 4, it says find the magnitude. Magnitude means how long the vector is, right? Okay, magnitude, how long the vector is. So we're starting at 5, 9.
What is adding?
Let me think. Starting at 5, 9 and going to 7, negative 2. So we're going this direction. Starting at 5, 9 and going to 7, negative 2.
Isn't it 8?
Wait a second. We're going down this way. Bleh. You don't have to graph this. 5, 9, and 7, negative 2 is like down here. Okay? That's what that vector looks like-ish. Okay? We need to find the magnitude. So if I think about him in terms of a right triangle, looking at 5 and 7, how many units have you gone in the x direction?
Just subtract them.
Actually, you know what? Let's do this first. Let's do the component form of him first. Okay? Do his component form first, and then you'll see how this works. From 5 to 9, how many units am I going?
5 to 7.
From 5 to 7, I mean. You're going 2. Is it a positive 2 or a negative 2?
Negative.
Positive.
Positive. You're starting at 5 and going to 7, so it's positive 2. You're going from 9 to negative 2.
7.
It's down 11. Starting at positive 9, going down to a negative 2 is negative 11. This is the component form. This is 2, this is negative 11. So to do the Pythagorean theorem, I literally use those two numbers in my Pythagorean theorem. Once you have the component form done, those are the two numbers that you use, right? 2 squared plus 11 squared and the square root of that. That's going to be my magnitude, or how long the vector is. 4 plus 121, the square root of 125, and whatever that is. 11.8?
11.1.
Oh, 11.1? 2?
11.2.
11.2 is the magnitude, okay? So maybe it would be better to do the component form first and then just use those numbers to find.
Wouldn't it be minus 11 though? It's gonna be the same.
Right, because when you do 11 squared, it's the same thing as negative 11 squared. I just don't ever put negatives in there because they're going to turn positive. So it's just extra work for me, okay? So component form might be easier to do first and then use those numbers to find the magnitude, okay? Just the Pythagorean theorem.
You were really trying
All right,
to trick us with
good?
that one.
I was trying to trick you with that one.
Work out.
Work ya? Well, then it's good that we did it together. Bye.